Pablo Palacio from Kouros. Muriel is sitting there, but Pablo will be talking for our dear co-organizer.
¿Sí? ¿Cómo hago para...? Debería... Espérate. ¿Sí, no? Okay. As briefly as possible, I will show some examples of the work I'm developing with my colleague, Muriel Romero. We form a team. He's a dancer and choreographer, and I'm a musician. And along the past 7 years, we tried to look for connections, for a common substrate between dance and music, which is not very difficult because there is a very intuitive connection between these both phenomena. Well, I have adapted a little bit this presentation according to what we have talk these days, no? And I will show some examples of previous works, and then I will mainly focus on the last one, the last work we did, so it will give an idea of where we are now, Muriel and me, and also it kind of expanded the scope of our work because included not only relationships between sonic gestures and dance gestures, but also synthetic visual gestures, okay? So, the first example I would like to comment is how we started to work on this relationship. And so we found that the Lavand F4 shapes indeed related very directly, no, to sonic gestures. No? Dubbing is a very brief sound, it's like a pizzicato of a cello, and the gliding is like a glissandi of a pizzicato. So depending on the sensory motor coupling that you impose on a vibrating body, you get a different sound. It's a very intuitive notion. No? So the idea was to create a composition using these Lavand F4 shapes, these kind of gestures. So we did a bird treaty, we call it Acus Matrix, and it consists on a dome of loudspeakers, a set of 16 loudspeakers, inside which the dancer develops the gestures that also create the transformations, okay? So at the beginning of each scene of this piece, Acus Matrix, you listen to the actual sound of the bird, okay? In this case, it's a very brief sound of the peak of a tetraurogallus, like a capercaillie, I think it's in English. And it's a very short sound of 10 milliseconds. And the idea is to transform it and to create a syntax, no? And also to play with the idea of William Blake, that to see the world in a grain of sand, in this case, the world in a grain of sound, okay? It's a very classical approach, no, of theme and variation, but we play a lot with the darkness. So the idea is that the audience is imagining the gestures, the choreography that is producing these sounds, no, from this kind of tiny grain. Okay. So then we try to expand, to translate this idea to the organs of the vocal tract, no? And to explore certain types of sounds, of phonemes, that have an analogy with the activity of the vocal tract. No? For example, if we think in phonemes like slide, no? We see a store of the energy in the edge, like it's like a noise, like a very complex structure, and then how the tongue slides over the velum, no? And also there's an analogy with the meaning of that. It's a sliding thing, okay? It's a very simple and intuitive idea that maybe is in the origin of language, no? And how the gesture, the language, and the music is connected to our physiology, and can also serve as a basis for a choreography, okay? So this is a couple of examples of the voice of the dancer. So this is an S, pure energy, that passes to a constriction of the lips, the P, and then is fragmented in the R, like in an iteration, no? And now how can we, again, apply the Laban efforts, no? How to create like bigger, no? Augment the gestures, make it stronger, thrust it, and play with this dynamosphere. There is only one speaker working. No puedo dejar. There is only one speaker, so it's half of the music. Okay, I will skip that one because it created like the idea of movement. Okay. What? No, there was only one. Well, okay, I will. Okay. Because then maybe it was a cable. Okay, then this is an interactive example of this kind of work, in which we go from one effort to another one. We go from thrusting. The dancer throws the sounds around an octophonic installation, and then it transforms the sound, like cutting it in small pieces at each movement. And in the end, the vocal sounds are reduced to shreds. No? So this also changed the quality of the movement. Okay, so the next step was to move from sound transformations and only relationships between natural gestures and sonic gestures to synthetic gestures. So we created this piece, Stokos, which comes from stochastic. No? The Stokos is the target, and the piece is based on transitions from deterministic structures to undeterministic structures. No? The Stokos is the target, so every time you want to hit it, actually you never do it. No? It's something that the Greeks realized, no? When that is impossible. There is always some perturbations, no? of the data of our intention. Okay, so we combined stochastic synthesis, which actually gives the name to the piece, with swarm simulations, a branch of artificial intelligence that studies the emergent behavior of large groups of animals. And the activities that we see on stage in this piece are sustained by these algorithms. No? On one hand, the Brownian motion of microscopic particles, which is the basis of the stochastic synthesis, the so-called random walks, which is a very interesting approach because you go directly to the sound wave. You don't arrive to a complex structure adding simple trigonometric functions like sine waves, but you articulate the sound wave through breakpoints, and you control each breakpoint with a random walk. So this gives the sound a kind of liveness, no? Which sometimes is difficult to achieve when we are working with purely synthetic sounds. No? And the music of the piece is totally synthetic and totally generated with this algorithmic approach. Another algorithmic relationship is the one that we established with the choreography. Because the same structure that generates the music, these random walks, is used to restructure the choreographic variations, like we see in this example. So the same variation is performed on two different parts of the stage by the two dancers, and this creates a sort of reverberation. Okay, so we go to the swan simulations, which also have a true choreographic nature. Okay, and the parameters that are used to modulate the structures are very familiar to choreographers, no? Like alignment, turning amount, we see here, cohesion, mass, that are also parameters very familiar to contemporary musicians, no? Also. So there is a true choreographic nature in the visualizations of the piece, but also a mathematical model that describes the trajectory of a particle in the air. No? It's like the dance of particles that generate the sound also. So there is a connection between the stochastic synthesis and the swan simulations. Is one of the extensions that we wanted to put forward in Stokos to the Senakian algorithm. So this is somehow the basis of the piece, algorithmically speaking. We didn't use the standard implementation of stochastic synthesis that comes with Super Collider because it includes some kind of simplifications. We did our original one. And now I'd like to comment how this is integrated on a stage with the dancers, no? Because in this piece there are on a stage two types of entities. We have the dancers, which are the natural entities, and the simulations, which are the virtual entities, the synthetic sounds and the swan simulations. And they are able to see each other with a computer and detection software. We use two types of tracking systems. On one hand, a 3D system in the front that detects the type of movements. It's a slow system, but is very sophisticated, developed by one of our collaborators. And then a top-down camera to detect the position on stage, and another camera on the corner, a 2D, very fast system for interactions with sound. This is one of the tracking systems on how, well, I will skip this. Well, I skipped this one. Oh, yeah. And how the swarms, for example, follow the contours. Okay. So, an important point for us is the degree of autonomy of the virtual elements, and this is related to the term, to the idea of interaction. No? Is it interaction when we create a movement, produce a movement, and there is a sound that responds, or we need a feedback? No? So depending on the degree of autonomy of the virtual elements, we can have the sounds acting like a natural phenomena controlled by the body of the dancers, or they can behave like partners in a collective improvisation. So this would be an example of transformation of the perceptual field in the piece, in which the dancers control with the movement directly the simulations and the synthetic sounds. And this is another example in which we use both systems, a very fast system, in which allows us to give rise to the agents that compose the simulation. And you see at the beginning that the dancer makes 5 gestures that creates the agents, but then the agents start to behave with a higher degree of autonomy and become like partners in a collective improvisation. You see, it's a very simple relationship. When the dancer moves, the agents stop and look at in a stochastic chord. And when she stops, they start to move and to perform their own choreography. Okay, then I will finish with this, the spatial relationships. The piece is developed in an octaphonic ring that surrounds the dancers and the audience. And there is these two rectangles that are used as projection surfaces, continuous, so the projections move continuously from the floor to the screen. And depending on how these virtual projections, these virtual entities are distributed, we can have a natural property on the stage, like water or hair, because these swarms, they gather together and can generate complex structure from these tiny elements. And they can behave like partners, like virtual dancers, but also can be concentrated in the body of the dancers and operate as an artificial skin. I think I will stop here because we are not much time left. So, thank you.